Going to cover 6 basic trigonometric functions constructed in a triangle though. So this is called right triangle trigonometry. Sorry. Screen froze again. So this is only a trigonometry on right triangles. There is also unit circle trigonometry, we will see later. And you will use it in real calculus class as well. So this is kind of introduction to trigonometry. We are exploring things on a right triangle. Okay. So far what we learned in chapter 5 is you only know what an angle is, how to measure it, how to change it to radian and degree. Okay. And today we are kind of building the functions using angles. Okay, so everybody knows what a right triangle is, right? Why do they call it right? Where does the word right come from? This is a right triangle. What makes it right? The angle right here. This is a right angle. We call right angle the one that measures 90 degrees, or in other words pi over 2 radians. That angle makes any triangle right. Good. And these two sides are called legs. The adjacent sides to that right angle, the one on the right and left around the right angle, is called legs. And what is this one called then? The one opposite to the right angle is called, it's already here, hypotenuse. Okay? And what is the most famous theorem you know about right angle triangles? There is a very famous theorem. Anyone knows? Pythagorean theorem. It's leg 1 square plus leg 2 square equals hypotenuse square. So what do I mean by leg? Any one of these two sides first, like 4. It's given 4 here. It's given 3 there. And when you square this, it makes 16 and 9. When you add them, they make 5 square, which is 25. And what a coincidence, 5 is actually hypotenuse length given. Anytime you square the legs and add them up, you get the square root of the hypotenuse. That's what Pythagorean theorem is. We will use this. Okay, so I'm going over this basic stuff you already know. So somebody took any two of these 3 sides. You have 3 sides, and pair them up and create a ratio among them and called it a name, called it a function name. Yeah. Sine, cosine, tangent, cosecant, secant, and cotangent are all produced by just random pairing of sides. Opposite hypotenuse, adjacent hypotenuse, opposite edges, hypotenuse, opposite, hypotenuse, adjacent, adjacent, opposite. A crazy guy just sat down and paired them up and called them a name. You could have come up with your own name if you have first built this. I'm just making this up, but yeah, sine function is nothing but opposite over hypotenuse. Unfortunately, you have to memorize all this. Probably you know majority of these already, right? Sine function, if you want to compute sine of an angle, you spot that angle. Let's color it. Where is our angle? Our angle is right in this corner. It's called theta. Sine of theta is you go hit the opposite side. This is opposite. And record it, which is 3. And then you go hit the hypotenuse. Hypotenuse is always the longest side opposite the right angle. So this is hypotenuse. You record that. And you take the ratio. 3/5 is how you compute sine of theta. Let's do another one. Cotangent, for example. Cotangent is adjacent over opposite. So adjacent is the one right next to the angle, is 4. Opposite is again 3/4. How easy is that? Okay, so until you get used to this, keep this table on the side, but I expect you to memorize it after a while, okay? You probably do. How many of you guys know this by heart? You all know? More or less? Okay, in case you forget, go back and review this. Alright, let's do our first activity. It says Pythagorean theorem, the one I mentioned earlier, to find the length of each missing side. What is given then? Which one is missing? We are given one leg, no, two legs. So where are the legs? These two, right? So this is 3, one leg is 3, this is 6. Two legs are given. I just put them randomly like this. Is that okay? So missing side is this. I will call this X. There is a third side required. I don't know. I call it X. No? You don't like it? Why? You want to put 3 here and 6 there?
No, also 6 and X.
Right. Legs are not these. This is hypotenuse. The longest side is always hypotenuse because this is the perpendicular side. So legs are either one of these. So you can put 6 or 3 randomly anywhere you wish. Usually go with the short side is 3, long side is 6. This looks longer. I don't know. Okay. So which side is missing now? Hypotenuse is missing. We need to find that first. That's the first part. Find the missing side. And then you are supposed to build 6 trig functions, sine, cosine, tangent, cotangent, secant, cosecant, using this triangle. Without knowing this hypotenuse, you can't get them. Alright, let's do it. Leg 1 squared, leg 2 squared equals hypotenuse squared. That's it. Right? This is the relation. Let's compute this. 6 squared is 36. 3 squared is 9. X squared. 45 is x squared. Now how do I get x? I need to take square root of both sides. Shall we put plus and minus? That's what I told you earlier. When you're solving an equation, make sure you put plus and minus whenever you use a square root of both sides. This time you are safe. You don't have to put a plus minus. Only plus, because we are talking lengths here, length of each side, and length is only measured in positive terms. But you better reduce this, compute entirely if possible. If this is a whole square, do it. Otherwise, simplify it by breaking that number into factors. What are the factors of 45? Isn't it 9 and 5? And 9 is double 3 and 5. Can you save any of these out? Can you get any of these out? Whenever you have a square, that factor comes out without the square. It loses the square, but comes out free and clear. But 5 is still stuck. X is 3 root 5. Just reduce it as much as you can. Alright? So we got hypotenuse as 3 root 5 centimeter. They expect a perfect exact answer. Don't round this off. Don't compute this with a calculator, because root 5 cannot be computed as a terminating number. It's a never-ending number. So don't use a calculator here. Okay, 3 root, this is how you make root 5, right? Check. Alright, now it's time to compute the promised 6 trig functions. Let's do them one by one by looking at this triangle. Okay, here's the question. Which side, where is the theta? Theta can be this or that. It's very important where the theta is, right? So we need to go read the statement to locate which corner is marked theta. Theta here is the opposite, the shortest side. theta must be opposite the shortest side. Which one is shortest? Isn't it 3? So theta is here. Okay? So sine theta means, what was its definition? Opposite over hypotenuse. What do you see on the opposite side? Go hit the opposite. There you go. 3. Where is the hypotenuse? 6? No, 3 root 5. And look at this. Cancel this. And the result is sine theta is 1 over root 5. Okay, I want to point out something here. What's rationalizing denominator mean? What does that mean? So is this okay? Is in my answer I have 1 over root 5. When I enter this, will the connect math like it? No, it won't. What is irrational numbers? These square roots, when they are computed, they are never ending. This is probably 2 point something, but they never end. That digit keeps changing and goes indefinitely. We call such numbers irrational. They never stop. You can't turn it into a ratio of 2 numbers. So this is an irrational denominator. There is an irrational number in the denominator. We can't have it in our denominator. In math, whenever you see a square root in the denominator, we need to clear them. I wonder how I can clear the square root here. So when I'm putting my answer, this is not liked. So how can I get rid of this square root? Oh, I know the solution. Can't we square both sides? And this way, 1 square is 1. Root 5 becomes just 5 because square root and this cancels. Can I do that? If I'm proposing a method, usually it's wrong, right? You don't trust me anymore. Yeah, it was wrong. Why? Look, just think like this. You have 1/3 of a pizza. You split a pizza into 3 pieces, you have 1 slice. When you square it, do you still have the same size slice? No, it's 1 over 9. You have 1 out of 9 slices. Your slice shrink to very little size. So when you square a ratio, you are destroying it. But I want to keep this ratio without destroying it. This is a distraction. Bad. Squaring both sides spoil the ratio. It's not a lot. Unless it's an equation. Yeah, if it's an equation solving question like this, yes, you can square both sides, but you're doing it to both sides. Here there are no both sides. You're only doing to one side. It's not a lot. Okay? Alright, then if I can't square it, what can I do? I'm not squaring it. What's the recipe to get rid of that square root? You cannot square both sides, but we can multiply both sides with anything you wish. Squaring is bad, but as long as you multiply both sides, you are fine. Same thing. Right. Just copy whatever this root is to both sides. So this way you have double. Whenever you have a double square root with same terms inside, they turn into no square root. What is 1 times root 5? It becomes root 5 over 5. So this is how you rationalize denominators. Basically you multiply by the same thing. Top and bottom. That square root must be copied, cloned, and put it on both sides, top and bottom. Okay? Alright, so our first one is solved. Root 5 over 5. Alright, you need to do the others, cosine, tangent, etc. Alright, let's do it quickly. What is cosine theta? Cosine is adjacent side over hypotenuse. This is opposite side. This doesn't qualify. What is the adjacent side? 6, right? 3 root 5. That's 2. And this time 2 root 5 over 5. Look, I'm rationalizing quickly. Multiply both sides by root 5. 2 root 5 over 5. 2. Can't fix it anymore. Alright, just clean it up. Choose. Oh, I can go in now. Okay. 2 root 5 over 5. Alright, these are a little bit pain to type in, so I'm going to leave that to you. I will just compute. Okay. Tangent theta is opposite over adjacent. Opposite is 3, adjacent is 6. This is easy, 1 over 2, right? Cotangent theta is, oh, it's opposite of what we wrote earlier. Adjacent over opposite, so I believe these will be flipped. So it's 2 over 1, which is 2. So if you get tangent, actually cotangent will be flip of tangent. You can flip the result in tangent and you get cotangent as 2 over 1 or 2. Why? Why do we flip? Because these two are flipped. Flip. Okay? And secant, what was secant? Yep, hypotenuse over adjacent. Oh, look at this. It's opposite of cosine. Not opposite, it's reciprocal of cosine, flip of cosine. So if you flip this or flip that, you'll be fine. Again, hypotenuse is 3 root 5 and 6. Cancel those, root 5 over 2. Look, if you wait, if you flip this out and then cancel, you get root 5 over 2. 5 over 2 root 5. When I cancel these, and this becomes root 5 over 2. Because 5 has root 5 over root 5 times root 5. You cancel one of them and get only root 5. So they match. And finally, cosecant theta is hypotenuse over width, opposite. What is hypotenuse? 3 root 5. Opposite is 3 root 5. 1, 2, 3, 4, 5. All 6. You type in, you're done. Okay? Any questions? Are we good? Alright. Guess what? I'm gonna need another one of these. I need this. Right triangle is always our source. Now, what's given here is theta is an acute angle, that means it's less than 90. Of course, it has to be less than 90, so to become one of these corners, it has to be less than 90. By the way, yeah, right angle trigonometry is only for angles between 0 and 90. If you want to compute sine 120, for example, you can't. So right angle trigonometry is limited trigonometry. You can't get every answer from this section. That's why we need unit circle trigonometry coming up later. If it's only less than 90, you can work out this triangle. Alright, we are given sine theta root 5 over 5. We are asked to compute cotangent. Okay, what is cotangent? Definition of cotangent is, what is it? Opposite over adjacent, is that right? Adjacent over opposite. Opposite over adjacent is tangent. Cotangent is its reciprocal, right here. It's adjacent over opposite. So I need to first mark any one of these corners as theta. Which one you want to call? This time I want to call this theta. Alright, this is my theta. This is opposite. This is adjacent. I need to know these two sides. Okay, now what do I know? I know sine theta, which is root 5 over 5. But what is sine theta by definition? Sine theta is opposite over hypotenuse. Okay? Now, you can fix these sides and hypotenuse any number you wish. You have the freedom, like 1, 10, and then 101 square root, like this. But these three numbers you pick must have this ratio. You have the freedom, however, your opposite over hypotenuse ratio must be this. So the best way to satisfy this requirement is choose opposite to be root 5, hypotenuse to be 5, and then yeah, you will have that ratio. Okay? So what I'm gonna do is here choose opposite to be this number, hypotenuse to be this, and compute adjacent one accordingly, because we don't know it. You can't choose this one. You can't choose all three. They must satisfy Pythagorean theorem. So the third one will come from Pythagorean theorem. Okay? So right now this is unknown. X. I have root 5 and 5. Again, how did I come up with root 5 and 5? With this. Could you choose 2 root 5 and 10 here? Could you come up with these? Could you do this? Yes, this is still okay, because 2 root 5 over 10, when you cancel, is still this ratio. You can do this as well. Can I do a 3 root 5 and 15? Yeah, ratio is still the same. As long as you have the same ratio, you can enlarge these numbers as you wish. But we want to be economical, don't waste numbers. Get the least amounts possible giving this ratio. It makes sense to take them as they are. Okay? Alright, now how do I get x? Let's set up our Pythagorean term. It says legs, which is x squared plus root 5 squared is hypotenuse, which is 5. Agree? What is missing? 5 squared. So x squared plus root 5 and root square cancels. 5 squared is 25. X squared is 20. So x is root 20. But I'm not going to write root 20 here. Instead, I will write it as 2 squared and 5. How did I come up with this? I first split 20 into any two numbers I know, 4 and 5. And then I broke 4 into 2 squared. And I got a square. Once you get a square, they won't stay in. They will break the prison and escape from that square root prison. And we'll make 2 root 5. This is 2 root 5. Okay, can you get the cotangent now? Which is adjacent is now known. Opposite was already been known to us, which is 2. Okay? Moving on, any questions? So here is the story. Build your triangle, put down what's known, find out what's unknown by Pythagorean theorem, make your asked trigonometric function by using the relations between the sides. Alright, now in the following two questions we are going to build some well-known values of some angles, sine, cosine, tangent, cotangent values of some well-known, widely used angles. What are they? You need to know 45, no, 30, 45, 60 of any trig functions by heart. These will be popping up a lot. What is sine 30, for example? Sine 45, cosine 60, that kind of thing. These 30, 45, and 60 are staple values. We need to build them and learn them. So by filling out this table. Okay? So how did they discover these values? They all come from a special triangles. First one is on the left is an isosceles. What's isosceles mean? Do you know what isosceles mean? Two sides equal. Look at this. This is a triangle with these two sides equal. In an isosceles triangle, if two sides are equal, of course they must be equal, then these two base angles, right, beside this right angle must be equal. So once you build a right isosceles triangle, these two corners must be 45. So by using any one of these corner angles, you can compute sine 45, cosine 45, tangent, any 45 of any trig function can be computed. For example, what is sine 45? It's opposite over hypotenuse, right? I'm using this one. Opposite over hypotenuse, 1 over root 2. But they don't like irrational denominators. How can you fix this? How can you fix this? This is irrational. Root 2 is never ending. You need to get rid of square root here. What is the rational form of it? Root 2 over 2. Yeah. Multiply both sides root 2. So you found sine 45. It's not been asked here though. Okay. Now, how do I get sine 30? They want sine 30, cosine 30, all sort of 30s. So I need to use this triangle for this. For 30 and 60, you use this triangle. Keep this in mind. 1 is 1 leg. Hypotenuse is 2. These are easy to remember. Leg is 1, hypotenuse 2. Okay. What is the missing side? You can actually build this on your own. You can find this by Pythagorean theorem. 4 minus 1 square is 3. Root 3 is this side. And once you know that, the short side, this is short side, will have 30 opposite to it. This is 30 degree. And the long leg, root 3 is about 1.8, so it's longer, but it's shorter than hypotenuse, of course. Long leg will have 60 opposite to it. So, what is sine 30? Sine 30 is come on, help me. 30 is the red angle. Sine means opposite over hypotenuse. It's 1/2. Opposite is this. Hypotenuse is always this. 1 over 2. According to red one. This is red one, or 30. Okay, somebody already constructed cosine 30, but I want to double check. Cosine is, for red, adjacent over hypotenuse, root 3 over 2. Yep, it checks out. Tangent 30 is opposite over adjacent. What is opposite? 1. Adjacent is root 3. Are we going to use 1 over root 3 here? No, we need to rationalize it as root 3 over 3. Cosecant. Cosecant 30 is, what is it? Hypotenuse over adjacent. Hypotenuse is 2. Adjacent is root. Is that right? Yeah, it's not adjacent, it's opposite. So this is not correct. What is opposite? 1. 1. So it's 2. And the rest, I believe they are right. Okay? That was part 1. What did they want in part 2? Okay, let's double check. 1 over 2, root 3 over 2, and 2. Yes, we got them right. In part 2, we are constructing a table for 45. Okay, and I already built the first one. Sine is root 2 over 2. What is cosine? Cosine 45. You can pick anything. Just pick this one. Cosine is adjacent over hypotenuse. It is root 2 over 2 as well. Interesting. Tangent is, what is tangent? 1 over 1. 1. Cotangent is 1. Because adjacent opposite is equal each other. They will still make 1 over 1. Okay, secant 45 is square root 2 hypotenuse over adjacent. Hypotenuse is root 2, adjacent is 1. Yes, you're right, root 2. Okay, cosecant 45 is hypotenuse over opposite, which is root 2 again. Okay, let's compare this. Root 2 over 2, root 2 over 2, root 2 over 2, and root 2. Okay? Alright, and the last one is we are doing 60. Sine 60, cosine 60, tangent, cotangent. I will just do it, a few of them, not entirely. The ones that's needed is tangent 60. Let's find tangent 60. So for 60, you're considering the blue angle. Tangent is opposite over hypotenuse. No, adjacent. Opposite is root 3. Adjacent is 1, which is root 3. What else is needed? This is root 3. Typing, let me do it. Secant is asked. Secant and cotangent. By the way, cotangent will be opposite of tangent. You flip this. Let's do cotangent first. You flip adjacent and opposite. In other words, 1 over root 3, which is root 3 over 3 when you rationalize. And what was the other one? Secant. Secant 60 is hypotenuse over adjacent. Hypotenuse is 2, adjacent is 1, right? For blue. This is adjacent for blue, which is 2. Okay? Am I that right? Let's see, root 3, root 2, root 3 over 2. Root 3 over 3. Alright, we got them right. Now I'm going to give you all of this already been in a table. So what we have constructed in this activity is already here, and I only marked this corner. This is for sure. This is no exception. You must memorize this. These are optional. You are free to memorize or not, because once we build some relations using these two, for example, you can obtain this one. You can get secant if you know this guy. You can get cotangent again using these two. So you can uncover all this, find out all this using this red box. So that's why I call this optional. But if you memorize it, it's gonna save you time. But if you feel it's hard, you don't have to. But know this side by heart. And it's not that bad. Look, these two are already matching, root 2 over root 2, root 2 over 2. So sine and cosine meets at 45. And for other values, they flip. Like sine 30 or cosine 30 is the same as sine 60. 30 and 60 are always opposite. So if you know sine 30, you know cosine 60. If you know cosine 60, you know sine 30. There are actually three values you need to memorize. 1 over 2, root 2 over 2, and root 3 over 2. Okay? Alright. But before that, let's do one more. We already memorized this, right? What is sine 60? Root 3 over 2. Again, if you need to construct, let's say you hesitate, which triangle are you going to use? You're going to use 30, 60, 90 triangle. This was 2, this was 1, this is root 3. You're going to use this triangle to make this. 1, 2, 3, but the 3 is under square root, okay? Now where is 1? 1 is opposite the smallest angle. 2 is hypotenuse, 60 over c is root 3. So again, sine 60 means opposite over hypotenuse, root 3 over 2. Okay, how about this? Sine 30 plus sine 30. Wait a second. I have a clever idea here. Isn't 30 plus 30 60? Can't we add them like this? 30 plus 30, right? I add these, and it is sine 60, and we already found out what sine 60 is, which is root 3 over 2, right? We can all go to the next question. It's just the same answer. Uh-oh. Oh my god. What's incorrect here? Unfortunately, there is no addition law like this. You can't combine inside and make two separate signs into single one. This is ridiculous. It feels like true. My gut's telling me, come on, you can add them, but no, it's incorrect. So how do we compute sine 30 plus sine 30 then? You need to compute each individually and add them. What is sine 30? You already know from the table, or you can get it here. Sine 30 means opposite over hypotenuse. It is 1/2. You add them, you see it doesn't match this 1. 1 over 2 and 1 over 2 makes 1, not root 3 over 2. Okay? So again, sometimes I see this. Some people see 75 is sine 45 and sine 30. Because 45 and 30 make 75. You separate like this and compute. Wrong again. You cannot split an angle into two ways and add them. No. There is a formula for addition. There is a formula to separate 75 into 45s and 30s. We will see later, but it's not as simple as this one. It's four-piece formula. It's not a direct addition. Okay? The right way here is 1. So this was a good example to show a common misconception. Are the values the same? Of course not. Alright? Now again, we're back to this table. From now on, I don't want you to compute sine of these angles by triangle. To save time, use tables. Memorization. And by the way, you need to know these common radians as well. We will keep using them. Again, what is pi over 4 stand for in degrees? How many degrees is pi over 4? 45. Again, whenever you hesitate, pi is 180. Split 180 4 ways is 45. Or what is the official way of doing radian to degree conversion? This is what you do. You multiply by 180 over pi, and that's 45. This is how we did it yesterday, right? So they are asking cosine 45, sine 45, first one multiplied by 6, second one multiplied by 7. What is cosine 45? What is it? Come on, it's right here. Root 2 over 2, right? Oh, what a coincidence. Sine 45 matches to cosine 45, and it's root 2 over 2 as well. And you have in total 6 plus 7 root 2 over 2 is 13 root 2 over 2. You have a feeling to cancel these, but don't, because you have to add these again, because these won't cancel and you have a denominator. Don't cancel, just add 6 and 7. 6 apples, 7 apples makes 13 apples. And these won't cancel. Okay? I'm not typing it. Make sure your denominator does not have radicals though. Always rationalize. Alright, here comes the promised relation to get the second half. Here are the relations between sine, cosine, tangent, cotangent, secant, cosecant. We already observed them somehow, right? Cosecant, for example, what is the definition of cosecant? Cosecant is hypotenuse over opposite, right? And sine is opposite over hypotenuse. What relation do you see here? Hypotenuse opposite, opposite hypotenuse. They are flipped. Technically, we call this reciprocal. They're reciprocal of each other. Cosecant is reciprocal of sine. You put 1 over sine. Sine is 1 over cosecant. So they are reciprocal of each other. Flipped. Like if you know cosecant is 2, sine is 1 over 2. If you know sine is root 2 over 2, reciprocal of root 2 over 2 is this. But 1 over a ratio is flip and multiply, flip and multiply. When you flip and multiply this is 2 over root 2. You kinda, if it's already a ratio, you flip numerator and denominator. Secant has the same idea. Secant and cosecant, secant and cosine are reciprocal of each other. So secant is 1 over cosine, or cosine is 1 over secant. Let's check out the table. Look. Secant. Look at the secant line. Where is secant? Here. And where is cosine? Here. Look, these values are always flipped. 1 over 2 is 2 over 1. 1 over 2, they actually did this. 1 over 2, they flipped and multiplied this and got 2 over 1. Root 2 over 2 is 2 over root 2 actually. But when you rationalize this, it's root 2. Root 3 over 2 is actually 2 over root 3. But when you rationalize it, it becomes this. It looks like they are not reciprocal, but actually they are when you rationalize it. So when you flip the answer in this column, you always get that. Same thing through for sine and cosecant. 1 over 2, 2. Root 2 over 2 is 2 over root 2, but it's rationalized to root 2. Root 3 over 2 is 2 over root 3, but rationalize it, you get this. So that's why I didn't ask you to memorize these if you know already these two. Okay? That's one part of relations. These two. Cotangent is reciprocal of tangent, and tangent is also reciprocal of cotangent. So tangent and cotangents are reciprocals. Same thing true for tangent and cotangent. Again, go to this table. Let's clear these. Look at the tangent and cotangent column, please. This is tangent. Here is cotangent. What do you see? When I flip root 3 over 3, I get 3 over root 3, but it's the same as root 3 when you rationalize. Flip of 1 is 1, so they match. When you flip root 3, you get root 3 over 3 and you rationalize it. Tangent and cotangent are reciprocals. If you know this column, you know that. How do I get this column? You will see how. This. Tangent is always sine over cosine. Why? I wonder how they come up with this formula. Look. What is sine? By definition in triangles, it is opposite over hypotenuse, right? What is cosine? It is adjacent over hypotenuse. When I take their ratio of sine and cosine, these two have the same denominator, so they cancel. And what's left is opposite over hypotenuse. No, opposite over what? Hypotenuse canceled. Opposite over adjacent. And what is opposite over adjacent? Tangent theta. So sine over cosine is tangent. Guess what cosine over sine is when I flip this? When you flip this, what do you get on the other side? What is flip of tangent? Cotangent. So cotangent is cosine over sine. It looks like a lot of formalization, a lot of memorization required here, but it's not actually not that bad. If you know the basic definitions, all these are straightforward. Okay? Make sense? Alright, practice until you get really fluent in these problems. If you're hesitating going back to tables, you're not ready. So it's practice that what makes it, unfortunately. You need to have grit, work patiently. Alright, we're going to apply what we learned into this question. We are given sine and cosine, look, of an angle in a triangle. What we want to find out is the remaining 4 trig functions. Tangent, cotangent, what else? Secant, cosecant. without, no, don't use this triangle, don't cheat. You can do this by triangle, don't do that. Use the relations you just learned. What is tangent in terms of sine and cosine? Let's see who remembers it. Tangent is, use sine and cosine only. Sine over cosine. So put the sine value onto the top, cosine value to the bottom. Same denominators cancel, and it's root 5 over 2. You can do cotangent two ways. You either do cosine over sine, put cosine to the top, sine to the bottom, simplify, or what is the other method? If you don't want to do this, what is the other way? Yeah, you can do cosine over sine, but I don't prefer it. What can you do? Flip this result, that's it. It's 1 over tangent, cotangent. That means 1 over this thing. In other words, 2 over root 5. Well, we can't leave our answer like this. We need to rationalize it by multiplying both sides by root 5. And I put root 5 to here. Root 5 times root 5 makes 5. 2 root 5 is the top. This is it. What is secant? 1 over cosine. 1 over 2/3 then, which is flip and multiply with the top. 3/2. You could have done it just right here. Just flip it. 3/2. Done. Cosecant is 1 over sine. Just flip. Flip this guy 3/5. 3 root 5, which is 3 root 5 over 5. Not too bad, huh? Right? So you will just type in these in the answers, in the answer box here, in each part. Oh my god, I'm doing terrible here. All wrong answers and missing questions. Get a bad grade. Okay. Alright, more relations. These are called Pythagorean identities. Because it looks like leg square, hypotenuse square, sum two squares again hypotenuse. It looks like Pythagorean theorem. They call this Pythagorean identities. Actually, they are really using those, okay? Pythagorean relation. So how do we use them? Again, no, this one definitely for sure. This is no exception. No this. What about the other two? Yeah, you can forget about them after this semester, but always know how to get these two. You want to see a trick? If you know the first one, you can get the other two. How? Look, sine square and cosine square theta is given 1, right? And what I'm gonna do is, I will divide both sides by, guess what? Cosine square. So I'm picking one of them and dividing both sides with it. Let's split this into two ways. Sine square over cosine square plus cosine square over cosine square and 1 over cosine square, right? Agree? Now, what is cosine square over cosine square? This cancels to Aren't they the same? They are same, they cancel and become 1. Okay, what is sine over cosine? Sine over cosine is tangent, but these are squared. This thing is tangent square. Tangent square plus 1 is, what is 1 over cosine? Secant. But if you square both sides, it becomes secant square. So 1 square is still 1. 1 over cosine square is secant square. Which one did I get? This. How do you get this one? Right, instead of cosine square, divide by sine square, you will get this. Alright, you're free to forget these two later semester, after the semester, but know how to get them when you need to. Alright, by division, simple division. Divide both sides with one of these, you're good. But never ever forget this. It's easy. Sine square plus cosine square makes 1 when you add. Alright, let's put this into work. The following question, sine is given, cosine is asked. Which one of these 3 equations are you going to use to get cosine? Sine is given, cosine asked. So you need to pick an equation that involves both sine and cosine. Which one? First one, of course. Write it down first. Sine squared theta cosine squared theta equals 1. Do we know sine? Yes, we do. Substitute that. But under a square, because this is sine squared, so it's 35 over 37 squared cosine squared theta equals 1. Okay, next. To get cosine squared, I'm going to move this guy the other side, which is gonna bring us this. Can I distribute squares like this? Is it allowed? Can I pass the square in right above these guys? Yes, you can pass this any power exponent into numerator and denominator. Now all you need is compute these, subtract from 1 and take square root. Cosine is square root of 1 minus 35 square over 37 square. You can set the common denominators if you wish. Multiply both sides with this. You get 37 squared over 37 squared minus 35 squared over 35 squared. Oh, you don't need a calculator here if you know your math. Yeah, you can do this by calculator, but this is a smart. No, this is 37. They have a common denominator now. Now this is a square difference. So it is 37 minus 35 times 37 plus 35. A square minus b square is a minus b, a plus b, remember? And this makes only 2. This makes 72. 2 times 72 is 272. And I will take 37 out. It has a square, so I'm moving it out. And 72 is 2 times 36. 36 comes out as 6. Double 2 comes out as 2. It's 12 over 37. No calculators used. Isn't that great? Again, 72 split into 2 and 36. Double 2 makes 2 when you take out. This is out now. And 36 comes out as 6. 12 over 37. Alright. Well, could you do this with calculators? I don't know. Let's see. Square root of 1 minus 35 squared divide 37 squared. No, your calculator will not give you the final answer. Algebra is better than calculus because if you put this is not an exact answer. ConnectMath won't like it. Okay?
If you use your calculator to put that into a fraction.
Oh yeah, yours can do that. Yeah, that can. Does it change to 12 over 37? Yeah. Okay. You guys are new generation. You're lucky. We didn't have those back then. Yeah, you can flip it into ratio and it will do that. Okay. Alright, this is where we're gonna stop today. We have a little bit something left here. 2 more questions, 2 more tables actually, and an application of what we learned into real life. That will be on Friday.